Hola a todos, buenas tardes y gracias por estar aquí. Yo voy a hacer la presentación en castellano, pero la charla de Javier va a ser en inglés, ¿vale? O sea que los que les cueste el castellano y dominen más el inglés, que no se preocupen. Bueno, para nosotros es importante llevar a cabo estas iniciativas, ¿vale? La verdad es que nos gusta participar de forma activa en la comunidad y es algo que en Codurance valoramos muchísimo, ¿vale? Para quien no nos conozca, pues bueno, nuestra misión es fomentar las buenas prácticas y los estándares de calidad en la industria del software. Tenemos unas raíces muy fuertes en la comunidad de craftsmanship, concretamente de Londres, y la verdad es que estamos muy contentos de poder aportar nuestro granito de arena a la comunidad de desarrollo de software. Hoy estamos con Javier Martínez, que es un conocido ya de la casa, estuvo hace unas semanas ya ofreciéndonos un workshop. Él es Data Engineer y trabaja actualmente desarrollando data pipelines, infraestructuras en el cloud, data warehouse y servicios de business intelligence, ¿vale? El anterior workshop que nos ofreció Javier lo podéis encontrar en YouTube, en el canal de Codurance. Os pasaré, si queréis, después la playlist y poca cosa más. Así que sin más, Javier, todo tuyo.
Thank you, Jordi, for this nice introduction. Welcome, everybody, and thank you again for coming today. And let me share, first of all, the screen. I guess you can see it. So I will go first through a really brief introduction with a presentation, and we will jump into live coding right afterwards, okay? So welcome. We are going to talk today and to work a little bit on Python and on WebSockets. I have to tell you a disclaimer. So it was announced to talk also about HTTP2. So I decided to put it aside because we will not have time. So if you are here because HTTP2, we are not going to talk about it. So, well, I hope you still stay in the session. So I have two goals today. First of all, that we learn together about WebSocket and Python. And the second goal is that we enjoy the whole process of doing it together. So for that reason, and to achieve these two goals, I would like you to interrupt in case you have any question. I know that it's difficult. I know maybe we are not so many people, but just feel free to ask. Or if you have later on at home questions, just send me an email. So what do we have in mind when we talk about WebSockets? So if I tell this concept to my mother, probably I mean, I translate it to Spanish and she will have something like this in mind, a spaghetti of sockets. And this is a joke, but the reality is not so far. If we imagine that the WebSocket, it's like the white one here that allows many connections points that are stable, okay? We have points within a server where we can connect and maintain that connection and that communication. Indeed, WebSocket is a protocol that was established in 2011, finally. You can check the reference down here. What it allows is to establish a full duplex communication between a client and a server. And this is different from HTTP, which both will be at the same level in the same OSI layer. Because usually with HTTP, it's the client pulling information from the server. With WebSocket, what we do is to establish a communication and keep that communication open so that both parts, both sides, the server and the client, can send information. And this open a really interesting situation or capabilities because we can use the server as a way to share communication between different clients. That's why, because of these capabilities, that is the typical examples or typical approaches when explaining WebSocket is the example of an echo that is a client writing something and the server just answering with the same thing, or a chat room in which many or different clients, different users join the chat room, and they write on the client application, and you can see how this information it's thanks that with an example about DICE. Specifically, something similar to this web app. I mean, there are many DICE applications in internet, but I use this called Ladinos, which translated will be a small dice. That is really simple. And I was using it, playing with it. I said, okay, this could be a cool example to show to the people how to implement something with WebSocket that is not an echo or is not a chat. So this is the plan for today. The plan for today is to build something kind of similar to this Dadinos application. Okay, now we have the plan, we have the goal, but what do we need? We will need, and we are going to focus on the server side, okay, on the backend side. Despite of that, we will need to provide some interface to the client, and will be the same server that will provide this access, okay? I really, maybe you know from the previous session here, that I like FastAPI as a framework for develop web applications with Python. It's really nice framework. So we are going to use it. Underneath, we will use Ubicon as a synchronous circuit gateway interface. We will have a different set of files, HTML, JavaScript, CSS. We will need to define some concept of the domain. I call this concept the croupier, because basically we need something that handles who joined this table and have some control, let's say, on who joined which table, okay? So this is the plan for today. And now I stop presenting and let's start working on the code. So you will see, I mean, this is the, can you see or can you read the fonts, the code? I guess so. I mean, sometimes it's a bit small, that's why I guess everybody can read it. Nobody complains. Okay, I continue. So the server.py is the original file, and you will have here the whole solution. I will refer to, or I will jump from time to time to this file to check parts of the code, to copy paste things that are really easy. For checking the packages, you can use this pip file. I like to use, you can use pipenv and just install when you download the repository, and you will have it will install all the packages. The logger.py and the croupier is because I split these two for being more tidy, but we will develop everything in a single .py file. Okay. Within the static folder, we have the different assets. So this is the different HTML files, the script.js, which is the JavaScript code that will work for the client, and the CSS, okay, and some other assets that are images. Okay, so let's start a new file, and let's server underscore live session .py. Okay, so because we are going to work with FastAPI, the first thing is to import from FastAPI, import FastAPI. So we can do this and define the application. So once we do this, we can make this call pip and run just to enter or execute within the virtual environment of pip and ubicorn. And we will change this because server online is the version I was working. And we call this file live session. And within live session, we want to call the app, okay, this, with one worker, and the reload is just anytime we have a change in the code, it will automatically try to reload or refresh, okay. So if we do this, we have that the server is running in this URL. If we go, okay, nothing is in place, so it's fine. But we need to start using or setting the interface for the client of this DICE application that we want to provide. Okay, and this file is this index file. Okay, that is here within the static. For the case of FastAPI, we can define static endpoints in this way. So if we want to serve just static HTML files, the way to do it with FastAPI is using the name of the application .mount with the method mount. Okay. It's complaining because a static file is not defined. So from FastAPI static files, import static files. Okay. Now, if we go to static here, okay, we have some initial version, some interface here that we introduce the name, the table. The table is the game table where we want to join with other players. Okay, and we can try to interact, and we see that something is happening. There are some errors, but it's normal. I will open the developer tools to see what is happening. There are some errors. Okay. One thing that I would like to change is that I don't want to enter each time in this static client. So for not messing everything up, let's generate an endpoint. And to generate an endpoint in FastAPI, we do something similar like this. Response type. Let's try to tell fast API responses import HTML response. We are defining here an endpoint at the root and telling that the response type will be HTML, and this function on this endpoint will be handled by this function that I call it, for example, redirect. Okay. And what we will do is to return some HTML, okay? And the HTML will be just redirect. I will just copy paste this because it's not really critical. And I will explain it to you. Closing this, okay. Okay, what we are saying is that this, when accessing this point, we will load this HTML and we will redirect. Okay, and it's not response type, it's response class. Okay, so now when we go to the root, we will be automatically redirect. Okay. Not sure whether anybody is there or listening, but anyway, I will continue. So once we have this, so first of all, we have this complaint here that is complaining about the course policy. The course is really always really painful to me. So luckily, Fast API provide a middleware that handle pretty well Fast API middleware course. Sorry. I will copy paste. It's much faster, and we can focus on the important stuff. So what we are doing here is telling, okay, import this middleware, and the middleware is a part of the code that will be always executed when a client access or HTTP server. And what we provide is just this, that we are telling that, hey, add this middleware to the application. So if we have this and we go back, try to do the same, we don't have this this complaint about the course policy. Okay, so we can continue focus. Okay, the application, the client application is kind of complaining about this endpoint that is stable. Okay, when we are working with this index HTML, which is the first file, remember, here, what we are doing is fulfilling a form and send the result to this client HTML file. Okay, and the client HTML file will generate the skeleton of the HTML, and the whole logic is implemented in this script.js. Okay, so I will go a little bit into this script.js to show you where we have to focus to follow the logic of development. Okay, so this script contains different functions, and this initial part defines the different dies that we are going to have in the application. In this case, we will have a D4 and up to D20. The generate role stats is something that I will explain at the end, and it's related with a library called Plotly. Generated die roller is the function in charge of generating these different interfaces. Create new player field is in charge of generating the different VIPs or interfaces for the different players. And the append role results is in charge of putting the different values of the dice on those fields for the player, okay? But the important part right now is here. When the page is loaded, we collect these parameters, the username and the table that are coming from this index, from this form, okay? And we store it. So we store this within my username and within my table name. In this way, the client application is aware of what is the user or player name, as well as the table where the player is registered right now. Okay, give me a second. Thank you. So at the end of the script, we call this define events, which is a chain of that is go up in that direction. So why? The define event is called here, but it's defined here. And we think the first thing we do is to register, okay? Calling this method. And within register, what we do is call request. And request is here. And what it's doing is posting or calling an endpoint and posting this body, okay? With the username and the table name. So from the server side, which is the Python side that we are working right now, the next logic step will be to handle or to define this endpoint, okay? In Fast API is as simple as this. I think it's called dice table. Async def dice table, for instance. And this will receive a body, okay? And the body will be a dictionary in our case, because as you can see here, this is what we are sending, username and table name. And the base table needs to receive that. So using or importing from typing, we can import dict. This is a cool feature from Fast API that it encourages a lot the typing of the different variables to manage or to check by itself based on this typing that the requests that it's receiving are in a proper shape. Okay. So if we do this and we put import, we put a breakpoint here, and we try to repeat the same, we have here the debugger stop, and we can check that we are receiving the body. And within the body, which is a dictionary, we have the username and the table name, okay? So the first step of this will be to track the tables that we have on our application. From the server side, the server needs to know which tables are created and which users are on these tables, okay? Because we are just showing an example of WebSocket, we create everything in memory, and we will create a class to handle this that we call groupier. And this is something that I showed you before in the presentation, that this will be in charge of the part of the domain. The class groupier will have something, the tables property that will store initially an empty dictionary, okay? So every new table will be an item within this dictionary, okay? So we can access the table by the name of the table and retrieve what it's inside. And we will see right now what we need to put inside, okay? So first step is to check whether the table is already there, or we need to append or put this table in the list of tables, okay? If it's there, we don't need to do anything. If the table is not there, we need to register the table. So we can call table name, from the body we can get table name, and we can check something like this. We create an instance of our group here. Sorry. Probably we want to have something like this, groupier get table, and we will send the table name, okay? So why? Because groupier is in charge of the management of the different tables and users. So we ask him or her, hey, do you have this table? If not, we will need to create with the table. If it already has, we don't need to do anything else. But groupier does not have this method, so we create, let's say, with async, because we want to have coroutines. Fast API is a framework that encourages the usage of coroutines, can handle both regular functions and coroutines, but one of its strong point is that it makes really easy to work with coroutines and async IO. So we are going to take this advantage for us. So get table, self, and table name. So because we are working in memory, this is really easy, or relatively easy. We can tell self tables, get table name, table name. Okay. And we can return it, okay? If the table name is not in place, we will return a none. So if it's none, then probably groupier, which is the manager, will have to create table based on the table name. Okay. One thing that we forgot here is that the coroutines need to be awaited. So if we now create another method, which is async also, create table self and table name. We will need to await both. Okay. So what is the logic within create table? So we have our dictionary of tables, and we need to add a new item with the key table name. Okay. The elements that we want to have for each item is initially maybe a list of users. Okay, this way. So the game is defined by having players within tables. So within each table, we want to have a list of the different users. Okay. So if this is the case, we have more or less everything in place. Now we need to know what is the application, the client application waiting for to know what we need to return. So checking the script.js, we can check that the response of request that is here is calling the table name. So probably, unlikely, we just need to return table name and the name of the table that has been already exists or that has been created, registered. Okay. So if we do this, we keep this, and we
Javier,
try to
sorry to
access
interrupt.
again, Javier, table 1. Oh, we see that we have some progress here because now we don't have any complaints. Sorry, every time we resize, we launch an event. So what is failing is this error, is WebSocket connection to this endpoint. So now we are in the interesting point of the whole presentation, which is the WebSocket, and we will go in a moment into this. Still, we cannot do anything, but as you can see, the complaint is that that WebSocket connection is already closed. So because there has no WebSocket connection, the client side assumed that has been closed and is not reachable. Okay, so so far so good. If any questions,
Javier,
just ping me.
there's a question on the chat.
So the key point of this talk is how to generate a WebSocket endpoint in Fast API. And it's as simple as this. The error point was complaining about table. So this will be like this. And we check that the last argument in the path is table 1, which is the name that we were getting. So it's a variable. And this will be handled by our WebSocket handler. Okay. So when we define a WebSocket with FastAPI, FastAPI is using the WebSocket handling implementation from Starlit. Starlit is the framework where FastAPI is built on top of it. So if it follows the same strategy, the same logic. The first argument in this case will be a WebSocket, which is of the type WebSocket. Okay, and this WebSocket type we can import it from Starlit, from Starlit WebSockets, import WebSocket. Okay, sorry, it crashed, of course. And then we need to add the table name variable that is coming from here. It will be a string. Now we can do a breakpoint here. Yeah, I need to write everything properly. Fast API WebSocket. Starlit WebSockets, import WebSockets. Name WebSocket is not defined. Sorry. Yeah, it's with capital S. So in this case, when we try to register, well, we have that the breakpoint stop, and we can check what we have here. We have the table name, which is the table name that we gave it before, and we have the WebSocket, okay, which, as you can see, is of the type Starlit WebSocket. We can take a closer look into WebSocket doing this. From all the parameters we have here, the cookie, headers, etc. But perhaps the most interesting right now is this client state. So WebSocket client state shows us that the status of the connection of this connection we talked here before is not connected, is in connecting state. So the server needs to accept that communication, that request, okay? So for that reason, the way to do it is to tell await, because it's a coroutine, WebSocket dot accept, okay? Now if we switch the place of the breakpoint, execute it again, we will have that our WebSocket client state is connected. So in this case, we have already the connection, and we are connected to the server, okay, and the server connected to the client. So one can think, okay, so that's all, that we are connected, and that's all. So we can continue, but in reality, the connection is closed. And this is the thing, the WebSocket will be connected while it's in this scope, in the scope of this endpoint. So we need to stay in this scope, awaiting for new requests from the client. For that, what we need to do is to generate a never-ending loop and try to read from that WebSocket. Let's see. Okay. If we do this and we do a PDB here and repeat the same operation, we now stop and we can check that we have already some data. And the data is telling us that there is an action which is registered and the username of the player or user that is trying to register into our application, okay? Let me import a logger, because import logging and define a logger. Set. Let me check 1 second, because I always forgot to set the logger, get logger. Okay. So we can now logger info here, connect it. Okay. And we receive some data. The issue with this situation, it's continuing. Let's repeat it again. So, okay, continue. We are connected, and you can see that if I roll, I will receive data. But what happens if the client close the application plus our server crash? And our server crash because there has been a disconnection that has not been handled. So the way to work with this is that we need to capture this exception and handle the exception in the way that our application needed. So let's define here a try. We try to iterate indefinitely and accept this exception is coming from Starlit, if I'm not wrong. Okay. And roll to accept logger info. Here we can catch it and put a client disconnect. Continue here. Quit, in fact. Let's put up the server again and go to the local host. Javier is trying to table 1 register. And now if Javier close, okay, sorry, I will remove before the breakpoint. Okay, let's we can logger info data just in case. Okay, so in localhost, join the table 1 register. And now we have the data. We are just printing. This is a classical example of the chat of the echo. So now if the user close the session, the server is not broken. It can continue receiving different players. So Victor, for example, the same table and register. Okay. So far so good. I guess. If any question, I repeat, you are more than welcome. Let's check the developer tools and check what is happening now. We roll, but we don't have anything here. So first thing, we need to do two main things. One is handling this register action, and second is handling this roll action, okay? Just to finish our application. So the logic for handling is something that we need to implement ourselves. Our own application can establish a contract or a protocol within the client and the server. In our case, it's just that the data, let's say action data, data get action. The action will define the different logic of the application and what the user will receive. So if action equals register, let's do just logger.info registering if action equals role, logger info rolling, and else logger warning, for instance. Yes, we tell this action is not supported by server. Okay. And we can, if we want, just to keep printing or keep logging the data we receive here. Okay, if we do this and we register, we enter and we have this registering. If we roll, we are entering and running. Okay. So let's start with the registering. So when we register in the application, we said before that we have the croupier has a dictionary with tables, and each table within that dictionary has a list of users. So what we have to do is to, initially in our mind, is to append the name of the user or any user information relevant to that list. Okay, so that is something that we are going to do. We are going to define a table, and we are going to await for croupier to get table based on the table name. And the table name is something that is coming in this endpoint. So we have it. If we make users equals table get users, this will be initially the so this will be, we stop here, we are here. So if we users is an empty list. our table is this. It is what the table contains. So we need to append some information about the user to this list, okay? So what is the relevant information about the users, about the current user? So believe me, when I say that we need to define this kind of fields, user name and roles. Okay. So what is the unique identifier that is relevant for us from the user point of view? In this case, is the WebSocket object. If you check again, or if we check together again, the pp bars WebSocket, we see that this is tightly related to one single client, one single user. Okay, so makes sense to store this object, this WebSocket, for further operations that we need to do with the user, and we will use as an identifier. Okay. The username is something that we are getting in this, you remember, data. We have here username, so we can data get username. And the roles is because this is a dice application for rolling dice, so we need to somehow provide that information inside. Okay, good. Once we updated the user's state, we can go to table and tell users is equal to our new users. Okay. We need to tell croupier, wait, let's await, croupier, set something like set table, because what I want to do is to update update the value of the current table with this new value. Okay, but of course croupier does not have this method yet, so we need to create it. Sync the set table, and we said that we need two things. First is the table name, and then is the table, which is the information we want to store within. Okay. So what we want to do, hence, is to, in the tables dictionary, go to the table name and just store this new value. Okay, table. So if we reach this point, and we continue here, and we try to do the same, we can check, this is a bit of practice, but we can access croupier.tables, and then we have that the table 1 has a registered user, the first place of this list, and the user is with a proper WebSocket object and the username and empty roles. Okay, so for the application to the client application to receive information about that this has been done correctly, we need to WebSocket send JSON And we need to define a payload, okay, that we are going to send back to the application, to the client application. And the payload will be type. This is, believe me, because it's a matter of faith right now, but we want to send this. So if we do it like this and we send this payload, wait, okay, continue. Sorry, type. I think it was registered. Let me check it. Yeah, register. If we do it in this way, we are storing in our server side the information about the user, and we are sending a frame back to the user telling, okay, the user has been registered. Okay, we send as a JSON payload. If we check it, okay, sorry, because users is not this, it's just a list of usernames. For user in users. Sorry. Of course, we cannot send the WebSocket. We cannot serialize it. So we just need to send the name. Trying this again. Continue. Okay. Ta-da! We have here the the player field, what is called the player field. Still, if we try to roll, we will not have anything, but at least we have the player. More interestingly is that if we localhost and now Javier try to enter in table 1 and continue, Javier is aware of that Javier and Victor are playing the same table. Okay, thanks that the server is sharing that information with the client part. Sorry. Okay, I will comment this for a while. So, but what happened with Javier, with Victor application? So Victor is only Victor. So Victor is not aware of what Javier is doing. If we repeat the logic, Victor is here, register. Javier is here, register, and same happens. And if localhost here, and if Miguel is joining, table 1. So Miguel is aware of Victor and Javier, but apparently Javier and Victor are not aware of the other players, not all the players, okay? Realize or notice something that the name of the owner of this client session is always on the top. So this will be Miguel, let's say, browser, Javier browser, and Victor browser, okay? So what is happening? What is happening is something that one need to take in account is that we are not sending the information with the users to all the clients, okay? In this case, WebSocket is the identifier of one user, and we are sending the information just to that user. But that's not correct. We want to broadcast to all the current users of that table. Okay, so that's the next step. What we need to do is for user in users, we want to await user get user, and because user get user will get access to this WebSocket, we can call it directly from here. Okay, saving, and let's try again. So now let's start with Miguel. Miguel is registering, and let's start with Javier and Victor. Victor is registering. Ta-da. Now we have Victor and Miguel, and also Miguel is aware that Victor is there. And if now Javier is joining, I will put it here. See? Javier is aware that Miguel and Victor are within that table playing, as well as Miguel and Victor are aware that all of the other users. So before jumping into the rolling, let's take a look into what happened if Miguel leave the table. Miguel leave, it disconnect, we go here, but the other clients are not aware that Miguel disappeared. And this is not something that we want in our application, okay? We want that when a client, a player, a user disappear or leave the table, the other user get notified and update the current view of the table, okay? So to make this more agile, I will copy and I will explain the code because it's pretty similar to what we have done with the connection, with the registering, okay? In this case, this loader, you can do this. In this case, when WebSocket disconnect, what we want to do is to pop that user from the list of user, okay? So because we are aware of the username, we can, and we are aware also of the WebSocket because it does not change, we can iterate through all the users, and in case the WebSocket object is the same as the WebSocket that we want to delete, just remove it from the users list. So we remove it and we update the state of the table. And once we update the state of the table, we generate a payload similar to this one with the register type and the list of the new users. And we broadcast to all the current users that are in the table. So we save and let's check whether this is the case. We have here Javier joining table 1, Victor joining table 1. We can have localhost. We have Miguel joining table 1. Okay. And now what happened is that if Miguel close the session, poop, automatically the other users are notified and the field for the player or the user Miguel disappear. Okay. Basically, the logic here is the inverse logic that we used before for adding a user. Okay. So the remaining part is what to do when we do some rolling here. By the way, one thing that you may like to know is that you go to your browser, and the WebSocket connection is in this part. I mean, we call it table 1. In this case, each socket connection has the name of the table, and the messages that are interchanged through this WebSocket are shown here, okay? And the different headers and so on. But the object or the connection is here. You can see that is a WebSocket type, and the status that is characteristic of this WebSocket is this 101, which is switching protocols, because we are switching from HTTP to WebSocket. Okay, saying this, just for you, that you can debug better, we need to implement the rolling. The rolling is something that croupier will have to take care of, because it's its responsibility. Okay? So async dev roll. So in this case, we have this dice information that is coming here in the WebSocket request that the different clients do. So data.get dice. Okay. So we will have this dictionary of values, you know? And the meaning of this dictionary is, for a die of D4, tell me the amount of dice of D4 that I want to, or you want to roll, okay? In this case, for example, the client or the user want to roll 13 dice of D6, okay? Because this is not really complex, or I think it's not really the key point. The key point we have already we have already gone through it, which is the handling and the different way to connect, disconnect, receive information, and send information back. I will just copy it from the already implemented version, and I will do the same. I will explain it to you. So we are here in the rolling area, and we just need to go to croupier and do something like this. Replace here plus. Okay. So let's analyze it a little bit. We have duplicate rolling. We don't want it. So in this case, we get the get dice, and we just call the method roll. Okay. And what roll is doing is just taking that dictionary, and for each item is taking the stripping the D, so we can have, in this case, only 4, the number of sides of each die, and then taking the value, which is the amount of time we want to roll that die, and roll it with a random library, which, by the way, it did not import. I have to do this. Okay. Sorry. we generate as many times as the value, and we return a dictionary with a similar shape, that is with a key, the type, and a list of values. Okay, so these dice results are put together in a payload that, again, we need to send to all the users back, okay? Because all the users should know what other clients or user role. That's mainly all. If we try to play with this, we will have a working application, I guess. Let's try to roll 10 boop. We have the results here. We can try to roll 4d6, 3d10, 4d10, sorry, and 1d20, and it works. If we register with a new user, Javier is joining, and we can put both clients side to side. And now Javier wants to roll 5d10 and 6. So it rolls, and Victor is also aware of what Javier rolled again. And this graph is just for a nice to have, that I love to have statistics of my roles. So that's why I put it there. That's mainly all. The server side is done, and we have our role application. So we are finished, and we are opening a small round trip of questions. Any question? So last advice from my side is that it would be cool, guys, if you go through the repository and try yourself. I still have pending to write the README for the repo. I will share it. I would like to receive any feedback from you. Any change, any comment, and that's all. You can reach me by email, by GitLab, or by LinkedIn, that I will leave my profile there. So that's all. Sorry, Albert, I didn't read the question. Does Fast API works on top of async IO framework? No, but yes, I mean, Fast API made use of async IO, but it can also work independently. So you does not need to define all the endpoints as coroutines, if that's the question.
Thank you, everybody.
I live here. Thank you very much for coming. Thank you very much if you reach this point of the video, if you see YouTube or in the future. And really welcome to all of you. Thank you.
Okay, thank you. See you all. Bye-bye.